Right. Okay, so we're here today with Ray White. Ray, thanks for coming in. Ray is the NetApp Worldwide Business Development rep. Is that correct, Ray?
Absolutely, Chris, in our data center business.
In the data center business. Fantastic. So, Ray, I appreciate you taking some time with us today. I wanted to ask you, I've been hearing a lot about, the AllFlash data center. What is NetApp's opinion on this, and what are your thoughts on that?
Interesting. Great question, Chris, and thanks for having me today as a guest. I really feel that the all-flash data center is a concept that is now. People think about it in the concept of there's so many components in the data center, multiple types of architecture, things that run the lights, mission-critical, revenue-generating applications, and unstructured data, and all these things back up and archive. When do we put them on flash? Well, Chris, something has really changed in the industry, and we're seeing this precipice finally happen where it's much more affordable to look at a non-spinning media solution than a traditional spinning disk. Now, I'm a NetApp employee for a very long time, and we sell spinning and non-spinning media, right? And we're also number one in capacity and storage operating system. So why would I take that position? Well, the economics just make sense now. So let me give you a couple examples. We worked with some customers recently who yielded a 2-to-1 data reduction in their current work set. And that's actually a layup, Chris. So that means that I take the data set, I put it on a NetApp architecture, I use data reduction technologies to reduce the footprint today, such as dedupe compression, and I use these data reduction technologies to avoid data consumption over the course of the life cycle of the asset. It makes sense, right? And we actually polled 700,000 NetApp worldwide systems, and the on average total effective capacity was about 6.4 to 1.
Wow.
So if you can just see a 2-to-1 data reduction, in other words, 100 terabytes appears as 200, we argue that the media type known as SAS is already fundamentally dead. So we're encouraging our partners, our customers, to stop buying and stop using spinning disks.
So that's interesting. It wasn't too long ago that flash was thought as, wait a second, that's really expensive stuff, and we only could put it on, as you mentioned earlier, tier 1 type of applications because wait a second, it's the only thing you can really afford it. But you're saying that the price points are coming down enough that the average Joe could have a, all flash storage system?
Absolutely, Chris. It's not only that price points have come down, it's that drive types and densities have increased at levels we've never comprehended. Let me give you a couple examples. Here in June, coming up next month, NetApp will be releasing a 16 terabyte 3D NAND SSD drive. We actually have a disk shelf on the roadmap right now for about 60 drives, so inherently 960 terabytes and a 4U footprint. By the end of next year, we'll have a 32 terabyte 3D NAND SSD drive. Mind-blowing. This is a petabyte or two in a 4U footprint. This was unbelievable to think about 3 years ago, where that was racks and racks and racks of an entire data center. And really now, the delta is we've seen a third generation of flash usage emerge. Not just about flash and speed. Everyone's flash is fast, so what? And that's why, Chris, when it first came out, the tier 0, tier 1 world, the database world, the things that fed the business and generated revenue for the business, that's where flash made sense. But think about the way Microsoft has changed the world. They released the SMB 3.0 protocol. They now allow the world's leading block-based databases like SQL and Exchange to run in the file services protocol. That's amazing. That's a great example right there. And then also NFS. Really, the NFS protocol, which was traditionally Linux, Mac, Unix, can now support Ethernet-based virtualization, and has for a very long time. But with the proliferation of virtualization that we see, with new protocols like SMB 3.0, traditionally in our data centers that we work with, we could see 80% of the environment be in file services or unstructured data.
Unstructured, yep.
Today, that makes sense on flash, based upon economics, based upon data reduction technologies, and lastly, the third generation, not just in speed and not just in efficiencies, but really in scalability. And we have built and worked with a really nice scaled architecture that we built called SolidFire. We acquired SolidFire for about $870 million. And as businesses are looking at private stack, cloud stack, OpenStack centric architectures to build catalogs and services inside of their business, it's another example of flash proliferation in the data center, and again a third dimension of efficiency, which is telling me and my customers why the all-flash data center is now.
So we're not suggesting that they rip and replace what they have today as far as the traditional spinning media, that NetApp is in that business as well. But are we suggesting as the depreciation cycle of that existing hardware that they've purchased, it's time to look at an all-flash system because it makes sense?
Absolutely.
Absolutely. Maybe not rip and replace what you have today, but at the end of the depreciation cycle, to take a look at some of the all-flash solutions.
Yes, Chris, it's because multiple protocols are needed in flash architectures, and most of these companies, again, who release all flash appliances or flash architectures focused on tier 1 block-centric SAN workloads. And with the ability inside of NetApp to do NAS and SAN, any protocol, anywhere, and to be cloud ready to get your data on-site and off-site as easiest as possible through native S3 protocols as an example, that's the difference between, say, an all-flash data center powered by NetApp and any of my competitors. They don't support NAS and SAN and all the protocols concurrently. It's different solutions. It's bolt-on. I hope it gets there. They're not cloud integrated and fully ready. And that true heritage and this third generation of, again, flash uses is what we're seeing and why NetApp is different and great.
Fantastic. So as we modernize the spinning media to solid state, what about the backup? How is that going to affect the backup? And do you see that changing over time as well? I mean, if you're modernizing from spinning to solid state, what is the backup going to have to look like? The storage managers that are out there, they have to consider something about the backup as well?
Absolutely. So SSD is even great for backup. Backup's built into NetApp fundamentally, and instead of just looking again at tier 0, tier 1, revenue generating, mission critical, massive databases and workloads, when you add the expanded file services and the unstructured data, the last two real big pillars, Chris, are backup and archive. Now, archive, I could argue and see that there is a performance tier and an everything else. And so where does backup fit into that? Well, backup has great needs for performance characteristics. Multiple streams, highly dense, how often do you access it, how often does your data change? So we really see that using backup on NetApp SSD actually gives much increases. It helps reduce the backend bandwidth for all the media servers and all the NDMP protocols. It gives you super fast response time. Obviously, flash is based on speed, we know that, but also the density component. I mentioned it in our all-flash architecture will have a 60 drive disk shelf. Well, in our E-Series Centricity architecture, which we acquired from Ingenio LSI, they have had a 60 drive disk shelf for 4 years. So now that I can put super dense, super fast compute, the chips are off the charts nowadays, and the capabilities we have inside the compute layer now make backup on SSD make sense, not just in economics, but also in performance, reliability, and speed.
Wow, that's exciting. It really is. I mean, it really is changing quickly.
It's exciting to embrace.
So I think the last questions I'd like to ask you, how do you see the data center of 2020? What's that evolving to?
Oh, wow. So such a big topic nowadays, right? We hear the term 2020, we all think, wow, that's very futuristic. Well, Chris, that's about 3 years out. Let's call it what it is. And so we, NetApp, are developing technologies now around 3D crosspoint technology.
3D crosspoint?
3D crosspoint technology, Chris.
Did you hear that? You heard it here first. 3D crosspoint technology.
Well, it's Intel's technology, but
Of course.
we're going to leverage it inside of storage and data management. And 3D crosspoint technology, what it will do for the world, what traditional NVRAM has already done, is it's not part of the storage overhead or the standard backup architecture. This doesn't have the SCSI overhead or all the different things that include storage I/O. It's basically a pure, simple NVRAM-centric system, which means you're not using spinning or non-spinning media.
Oh.
So Chris, theorize for me, just for a minute. I talked about 16 terabyte 3D NAND SSDs. Let's talk about what that is. First of all, everyone who's using SSDs today in the enterprise space are using 2D, and that has to do with the platter. So there's only so much die and all different types of SSDs, whether it's enterprise or commercial, so many different types. They all have different characteristics. How quick do they work? How long do they last? How many times can I use them over and over again? And so what we've seen in 3D NAND technology, which was released about a year ago by various manufacturers that make disk, but none of the major storage companies embraced it yet. NetApp will be the first. We're very excited about that. And all that means is we're going to take the platter and extend it and then stand it up vertically. So you'll have 3D NAND technology,
Wow.
32 and 64-bit pairs. Unbelievable. And that's how I can run a 16 and soon 32 terabyte SSD drive. 3D crosspoint technology, Chris, simply put, is just NVRAM that doesn't have the standard storage overhead. So when I actually have 16 terabyte NVRAM chips, I argue that companies won't be using spinning or non-spinning media in the data center of 2020. It's an
Wow.
interesting time.
Very, very interesting. Well, Ray, thanks again. Appreciate you coming in and sharing your
Appreciate
vision,
it.
your thoughts, and we appreciate it. And thank you, everybody out there. And we appreciate your partnership and tuning in.
Thank you.